So we're going to go back to these factors. These multiplying factors are what we see in the fractions as factors in the factored form. So this 5 over 10 is equal to 1/2, and we can show that by showing the factors of 10, okay, showing that they have common factors, this factor of 5. We can cancel out these factors. Okay, so this is one way we can show that we have equivalent proportions or fractions. Okay, and again, it's important to understand how that factor is involved. Sometimes we can show it like this, multiplying factor or dividing factor, divide by 5, divide by 5. Going the other way, we can, in fact, express that divide by 5 in this direction as a times by 5. Okay, so we can show this with these factors. We can show it in this proportional equation, and in this proportional equation, this is where we're going to show these kind of loopy diagrams. So we're going to have a times 11 factor going in this direction, okay, and in this direction you're going to have a divide by 11. Okay, so here we're going to have divide by 11, and we're also going to have our times by 11 going in this direction. We also have this proportion going up and down. So going from here to here, we have a multiplier of 0.375. Okay, we could do it the other way around, and that multiplier is not as nice. Okay, the vertical multiplier in this case, going in this direction, okay, is going to be times by 2.66, repeating, which I'm going to round to 67. Okay, so I'll just clear up that one down here. This is 0.375. Okay, so we have this times divide relationship within the ratios, and this is something that I want you to make sure you have a very clear idea of. Okay, and again, if we go times in one direction, we could divide by that same factor going in the other direction. Okay, so that times by 0.675 can be undone with a divide by 0.6, so 2.67. We have times by 2.67, so we can divide by 2.67 going in the other direction. Same thing here. We can, instead of timesing by 0.375 going up, we can divide by 0.375 going down. So now we're starting to develop some options here. And again, we can use that reciprocal multiplier, so 8 divided by 88, which is, 0.090909 repeating. We can use that factor to go between the ratios as well. Okay, so that's another way we can do it. We can also do this by showing that what we do to one side, we keep the equation balanced. Okay, so this is more getting into algebra. So what I can do is I can multiply both sides of the equation to keep the equation balanced. So if I multiply this whole equation by 12, so times 12 divide 12 will undo each other, so I get 2a on this side, and I get times 12a divide by 6 gives me the 2a, and we can show that they are equivalent to do the same, to get the same result. Okay, and we can show that these are equivalent proportions by doing. Now what happens when we do this though is we end up getting rid of our proportion. Okay, now we can do the times and divide on the top and bottom as well. So there is not only this balance between left side and right side of the balance, there's also this balance in the proportion in the top, the numerator and denominator of a fraction. So these are slightly different balance, but these are ways that balance shows up in mathematics. And balance is a very important property in math. So here, to find the unknown parts of this ratio, we could, we can actually solve for that. Okay, we can actually multiply both sides by 4. Okay, we can times by 4. Those cancel out, and we end up with 4 times 9 divided by 12. We get x equals 6, or so x equals 3. We can do it like that. Okay, we can solve it, although we haven't really done algebra solving yet, so we probably want to stick with proportions. We can show our multiplier of times by 3. I can solve by dividing by 3. Okay, and I can get the numerator is equal to 3 that way. I can solve this by factoring. Okay, I can do this in a few different ways. Okay, so this one here, we can again use our times divide factor. Here I could use my vertical multiplier. So if I want a multiplier, again, I divide. So 10 divided by 4 is going to be 2.5. So going in this direction then, I'm going to divide by 2.5. So 12 divided by 2.5 is going to give me, so 12 divided by 2.5 is going to give me 4.8. So in this case, Z is equal to 4.8. So we're starting to develop more and more strategies to deal with them, but they're really just based on this proportion. And understanding that if we have a times divide relationship, all we're doing is looking for a multiplying or dividing factor.